Hi everyone, welcome back to my channel Influence Mathematics. I hope you all are doing good. In this video we are going to discuss about chapter 12 exercise 12.2. In the previous video I have taught you how to solve the problems in exercise 12.1. Today we are going to discuss 12.2. So before we start the exercise 12.2, let me discuss some key points of this exercise. Just say this is a circle. This is a circle, and as you know, there is a center of a circle, and this is the radius of the circle. This is also the radius of the circle. Yes or no? So center of the circle, this is also the radius, this is also the radius of the circle. Now you can see this portion, this shaded portion. You can see that this shaded portion is the minor sector, okay. This shaded portion is the minor sector, and this unshaded portion is the major sector, okay. This shaded portion is called the minor sector, and this unshaded portion is called the major sector. Let me tell you the formulas of this minor sector and major sector. To find out the minor sector, the formula that you are going to use is theta by 360 pi r square. Theta by 360 pi r square. Okay. Now, from where I will get this theta? The angle that will be given for this sector, okay, the angle will be given for this sector. This angle is the theta here. Okay. Now, how to find out the major sector? Now, to find out the major sector, you have to find out the minor sector first of all. You have to find out the minor sector. Then, after finding out minor sector only, you will find out the major sector. The formula is area of circle minus area of minor sector. Area of circle minus area of minor sector. So in this way you are going to find out the minor sector and the major sector. Now let us discuss about some other points. This is a circle, this is the center, this is the radius, right? Now this is the minor sector, this is the major sector. If I draw this the chord, this is the chord of the circle. Now after drawing this chord of the circle, this shaded portion, can you see this shaded portion? This shaded portion is called the minor segment. This shaded portion is called minor segment. And this unshaded portion, this triangle and the remaining circle, all these are unshaded portion. Yes or no? So this unshaded portion is called together, okay? This unshaded portion is called major segment. Okay. Now, how to find out this minor segment? To find out this minor segment, first we will find out the minor sector, as I have told you in the previous circle. I told you how to find out the minor sector with this formula. So with this formula you are going to find out the minor sector, right? And here also, to find out the minor segment, first you have to find out the minor sector. Okay, first you have to find out the minor sector. The angle will be given here, and you have to find out the minor sector first of all. Okay, you have to find out the minor sector, as well as you have to find out the area of this triangle. Okay, so to find out the minor segment, the formula is area of sector minus area of triangle. Okay, To find out the minor segment, we have the formula is area of the minor sector minus area of the triangle. Then the remaining is area of the minor segment. Okay. Now, how to find out the major segment? To find out the major segment, you have to find out the minor segment. Then after that, you will find out my major segment. The formula is area of circle minus area of minor segment. Minor segment. The segment and sector both are different terms. Segment and sector both are different terms. Please don't get confused. I have told you this portion is called the minor sector, right? And in the minor sector, when a chord is joined, right, the chord is joined, and excluding the triangle, the remaining portion of this is the minor segment. It's called the minor segment. Let us discuss here some other points. Just like this is the circle, this is the center, this is the radius, right? Now this one, okay, this arc. Can you see this arc? Right, this arc which is forming the end portion of this sector. Okay, this arc is called this arc. Sometimes you will be asked to find out this length of arc. This is called arc. Okay, arc of the circle. Okay, so this length of arc, sometimes it is asked to find. How to find out this length of arc? This angle will be given, right, theta. The angle will be given. So how to find out the length of arc? Length of arc will be finding out length of arc. We'll find out by the formula theta by 360 2 pi r. Theta by 360 into 2 pi r. With this formula, we are going to find out the length of arc. Okay. So these are the major points. Number 1, the minor sector and the major sector. Number 2, minor segment and major segment. And number 3 is the length of the arc. Okay. Now let us discuss the problems given in the exercises. So here the first question that is given, that is area of the circle. Find the area of a sector of a circle. Sector of a circle with radius 6 cm if the angle of the sector is 60 degree. As I have told you while explanation that this is the circle, this is the center, this is the radius, this is also the radius, and this both the radius are given how much? 6 cm, 6 cm. Yes or no? And the if the angle of the sector is 60 degree, the angle formed, it is 60 degree, right? So we are asked to find out the area of this sector, area of this sector. Okay, this portion, this sector, we are asked to find out. So area of this sector, that is called, this sector is called what? Minor sector. So we are going to find out the area of this minor sector. Now what is given? Let us write down. Radius is given, radius of circle, it is given 6 cm, which we will name it as r, and angle subtended at the center, angle subtended at the center is given how much? 60 degree, which we will name it as theta. Done. Now area of minor sector, area of minor sector. What is the formula? The formula is theta by 360 pi r square. Theta, it is 60 degree as it is given here, by 360. Pi value is not given anything, so we will take 22 by 7. Radius, it is given 6 cm, so 6 cm into 6 cm. 0, 0 cancel, 6, 6 ja 36, 6, 6 cancel, nothing is left. 22 into 6, 132 by 7 centimeter into centimeter, centimeter square. So in this way we are going to find out the sector that is asked in the question. Here it is asked only to find out the area of the sector of the circle, area of a sector of the circle. They are asking only to find out this minor sector. Okay, if they would have asked to find out the major sector, then we should have done this portion as we have done. After that only we are going to find out the area of the major sector, that is area of the circle minus area of the minor sector. But since here they have not asked us to find out the area of the major sector, so we will stop here. So what we have done, radius of the circle is given, angle subtended at the center, it is given 60 degree. So area of the minor sector, formula is theta by 360 pi r square. Theta value it is 60 degree and radius it is 6 centimeter. So we have substituted the values and after cancellation we got 132 by 7 centimeter square. Let's see the next question. Okay, see here what is the question said. Find the area of a quadrant of a circle whose circumference is 22 centimeter. This is the circle, center, this is the radius, this is the radius. Here radius also is not given and angle also it is not given directly. But you see, read the question very properly. Area of a quadrant of a circle. Here the word quadrant, can you see that? Here the word quadrant, it means that the angle subtended at the center is 90 degree. Is how much? 90 degree. Okay, quadrant means the angle subtended at the center is 90 degree. That means 1/4 of a circle. One quadrant means 1/4 of a circle, and the center of the circle the angle is 360 degree. So for 90 ja it is coming 90 degree. So that's why it is 90 degree subtended at the center. I hope it is clear. So the angle we got. Now circumference of the circle is given 22 centimeter, right? Circumference is equal to 22 centimeter. Circumference formula is 2 pi r is equal to 22 centimeter. 2 into pi is 22 by 7, r equal to 22 centimeter. 22 cancel. Radius is equal to 7 by 2 centimeter. Done. So this is the radius and the theta equal to angle subtended at the center. Angle subtended at the center is given here 90 degree, right? So we are asked to find area of the quadrant, that means this area of the sector. Okay, area of quadrant is equal to area of the minor sector. Formula we are going to use theta by 360 pi r square. Theta it is 90 degree by 360 pi it is 22 by 7, and the radius that we got here 7 by 2 into 7 by 2 centimeter square. 0 0 cancel, 9 4 ja 36, 2 11 ja 22, 7 7 cancel, nothing more is left. I hope 11 7 ja 77, 4 2 ja 8 centimeters square. This is the area of the quadrant that we got from this question. In the question they have not given us radius, they have given us circumference. From the circumference we have used the formula 2 pi r and we have calculated the radius. Okay, 2 pi is 22 by 7, r 22 cancel, r equal to 7 1 just 7, these two will come down, 7 by 2 centimeter. And the theta, since they have given here quadrant, so that means quadrant means 1/4 of the circle. When the circle angle it is 360 degree, so 1/4 of 360 it is 90 degree. So that's why angle subtended at the center is 90 degree. So area of the quadrant formula, that is the minor sector formula, it is theta by 360 pi r square. Putting the values we got the answer. Let's see the next question. Okay, so here in this question, what does the question says? The length of a minute hand of a clock is 14 centimeter. Now let us draw a clock. Shape of the clock. This is the shape of the clock. It is in the shape of a circle, right? And this is the minute hand. This is the minute hand. So this is the minute hand, and this minute hand, the length it is given 14 centimeter, and we know this minute hand is going to be the radius of this clock, that means radius of the circle. So radius is equal to 14 centimeter. This is the radius given here, right? So this is the radius given here, and see, find the area swept by the minute hand in 5 minutes. In 5 minutes. Now theta equal to angle subtended at the center, subtended at the center. Now see, this is the sector, 5 minute sector, right? This is the 5 minute sector, okay? Like that 12 parts will come out, right? If we are forming all the sectors, 5 minutes. So this is the 5 minute sector. Now see, 5 minutes, to complete this circle we have to make 60 minutes, yes or no, right? 60 minutes, 5 minutes like that, 60 minutes we have to cover, right? So 5 minutes out of 60 minutes, 5 minutes out of 60 minutes. So for the center of the circle, the angle is how much? What I said you previously, 360 degree. 5 minutes they have given. They told that find the area swept by the minute hand in 5 minutes. This 5 minute sector, what is the area of this sector? 5 minutes, what is the area of this sector? Okay, they are asking to find out. So before finding out this one, we have to know the angle subtended here, right? Now in 5 minutes, total it is 60 minutes, right? One round, total it is 60 minutes. So out of 60 minutes they have given for 5 minutes. So 5 minutes by 60 minutes, then center angle it is 360, so into 360, okay? 5 minutes, since they have given for 5 minutes, so 5 minutes out of 60 minutes. If they will be giving 10 minutes, so 10 minutes out of 60 minutes, okay? Into central angle it is 360, so into 360. Minutes cancel, 0 cancel, 6 ja 36, 6 5 ja 30 degree is the theta here. Okay, angle subtended at the center is 30 degree. Now radius is also ready, angle subtended at the center is ready. We have to find out the area of the sector, area of the minor sector, or we can say area swept by the minute hand in 5 minutes. Okay, area swept by the minute hand in 5 minutes. That is the area of the minor sector. The formula is theta by 360 pi r square. Theta it is 30 degree that we got here. Theta is 30 degree by 360. Pi is 22 by 7, and the radius it is 14 centimeter. So 14 centimeter into 14 centimeter. 0 cancel. 3 12 ja 36, 7 2 ja 14, 2 6 ja 12, 2 3 ja 6, 2 7 ja 14, 7 into 22, 154 by 3 centimeter into centimeter square. So this is how we are going to find out the area of the minor sector. So today we have solved 3 sums where in the first sum the angle was given, and the radius to radius were given, and we have found the area of the minor sector, right? And in the second sum they have given us the circumference. And they have said that it's a quadrant. So since it's a quadrant, the angle subtended at the center we have taken as 90 degree, and from the circumference it is given, we have calculated the radius. So with that theta and the radius, we have found the area of the quadrant, that is also the minor sector. Okay, by theta by 360 pi r square, same thing. And in the third question they have given the example of a clock, which is also in the shape of a circle, and that clock radius is to be measured by the minute hand. So that minute hand length it is given 14 centimeters. So in this way we got the radius, And angle they have not given, but they have told us, asked us to find out the area swept in 5 minutes. So 5 minutes out of 60 minutes, total it is 60 minutes. 5 minutes out of 60 minutes, so central angle is 360, so into 360. Calculate it and we got here 30 degree. So angle also we got, radius it was given, and we have find out the area of the sector, that is the area swept by the minute hand in 5 minutes. Okay, and by the formula of area of the minor sector, that is theta by 360 pi r square, and we got the answer. So in this way, in these three sums, we have been calculating the area of the minor sector only. So in the next problems, we will be solving out how to solve for the major sector as well as the segment portion also. Till then, take care, be at home, stay safe, stay tuned, keep practicing the sums that we have done today. Thank you. It's Nirmal Roy signing off.